All right, so good morning, everyone. My name is Julia Paprocki, and I'm an assistant professor at the University of New Hampshire. I guess we went forward too fast, but I love estuaries. For those of you that might not be familiar with the geographic region of New Hampshire, the University of New Hampshire is located in what we call the Seacoast region, and despite the fact that we do have a coastline, it's only 13 to 18 miles long, depending on how you define it. Our region is home to two unique estuaries. And so since starting at UNH, I have started to work a lot more in this region because I happen to live there. And I've also found that a lot of my research is now focused in this area. And even though most people find that estuaries people believe that they belong more to natural resources managers, biologists, or water resources engineers, I fully believe that geotechnical engineers do play a very important role when we talk about the management of these systems. So just in case you're not familiar with exactly what an estuary is, estuaries are often defined as where rivers meet the ocean. At the intersection of where these meet, we have a very complex mixing of both salty and fresh water, and this results in a biologically diverse community. In general, though, however, estuaries can exist anywhere where two distinct bodies of water mix. So this can include a number of inland estuaries, such as where rivers are going to meet lakes. You see a lot of those up in the Great Lakes region of the U.S. Today, I'm mostly going to be talking about coastal estuaries because of the impact that they have on me, and I think that a lot of us also will be impacted by them as well. So as I mentioned, estuaries are typically biologically diverse regions, and as a result, we often refer to them as the nurseries of the sea. In the US, about 68% of all commercial fish catch and 80% of all recreational catch lives at least some portion of their life cycle within an estuary. And this includes a number of different fish species, such as salmon, herring, and striped bass, as well as a lot of different shellfish species, including blue crabs and oysters. One famous example that I always love to give is if you think about the Chesapeake Bay in Baltimore, blue crabs are very important for both the cultural and the economic value of those regions. So as geotechs, we contribute to this fishing industry by the design of anchors and moorings that might be related to fishing nets or to aquaculture farms. We also contribute to the design of infrastructure that's required to transport this catch to the market, whether it be the design of foundations for piers and docks, as well as the maintenance of ports by keeping those shipping channels open for the movement of boats through dredging activities. So right now on this slide, I only have a few different fish species that are shown. However, I do like to point out that there are thousands of animals that call estuaries home. I just have quite a few of them shown up here on this slide. And this can include, in addition to fish and shellfish, also other mammals like birds and also some otters, which I guess also goes back to my Travis Kelce fact, because he apparently also really loves otters. So estuaries are very popular for their recreational activities, and this includes things like birding, kayaking, and hiking. But in addition to those recreational activities and fishing activities, estuaries are actually responsible for somewhere over 7 trillion, and that is trillion with the T, part of the economy of the United States. So, which that contributes approximately 34% of the total gross domestic product of the entire country, which is kind of unbelievable. In addition to fishing and tourism, other common industries and estuaries that we can be involved with are things such as the energy infrastructure, marine transportation, and real estate. Coastal areas of the U.S. are home to over 31 million individuals. I myself am one of those 31 million individuals. And there are approximately 53 million jobs found within estuaries and coastal regions. Shown here on this map, I pulled out some of the most famous cities in the United States that are found on estuaries, and 4 of the 10 largest cities in the U.S., that includes New York City, Jacksonville, Houston, and San Diego, are also founded on estuaries. So a lot of people live within these areas, and a lot of infrastructure is built within these areas. So this can include things such as roadways, ports, docks, wharves, flood protection systems, levees, and a number of buildings. And so we'll call those our gray or our hard infrastructure in those areas. And so when we're building in those areas, we need to understand not only the soil conditions, which there can be a lot of complicated soil conditions, including things such as organics or really, really soft soils. For those of you that may or may not be familiar, Boston, for example, was founded on an estuary, and we know a lot of the complications in this industry that resulted from building the Big Dig and a lot of the challenges with the Boston blue clay. But in addition to that, we also need to understand hydrodynamic forcings and any natural hazards that can impact those regions. So one example that I always like to give is San Francisco, founded on a very well-known estuary. It's also a high seismic zone. I think we heard about that a couple times over the last couple days. And so we need to also account for that in our design in those areas as well. There's also a number of other natural hazards, such as slope stability, hurricanes, floods, and coastal erosion that all impact infrastructure in there as well. One other thing that I always like to point out is that there's a lot of famous ASCE landmarks and bridges that are founded in estuaries. I myself have actually gone on 2 separate vacations just to visit famous ASCE landmarks that are in estuaries and contributed to the economy of those regions, I guess. So I specifically, after I graduated college, went to go visit the Golden Gate Bridge in San Francisco. And also I've gone spring break my senior year to go to New York City to cross the Brooklyn Bridge. It was like the whole point of why I went on that trip. And those are both founded on tidal estuaries, and they have famous infrastructure that crosses them. Another one I always like to point out is the Tower Bridge in London that crosses the Thames River, because estuaries aren't a unique environment to the US, they're found all over the world. And one thing that I think is interesting to point out, and if you've never spent any time in London or near the water there, they have a tidal range of close to 7 meters, or 23 feet if you go with the US units, which is actually a pretty substantial change in the water levels and something we need to think about and consider when we're actually trying to design site investigation or infrastructure in those areas. In addition to all of this hard infrastructure that exists there, there's also a substantial amount of green or natural infrastructure. 2 pieces of green infrastructure that are important for estuaries are salt marshes and mangrove forests. These are typically found on our edges of our estuaries, and they're exposed to varying water levels and salinity levels throughout the day as well as throughout the year. Salt marshes are coastal wetlands found in mid to high latitude regions of the US that have shrubs and grass plants, while mangrove forests are evergreen plants that are found in tropical to subtropical regions. Salt marshes and mangroves provide us a lot of benefits, both from being fishery habitats and homes for birds and other aquatic life, but also serve a lot of benefits to humans. This can include things such as flooding protection, shoreline stabilization, and water filtration. One example I like to give is that as water flows into a salt marsh, I often think about stormwater runoff from a road. It slows down over that salt marsh because the fronds of those plants slow down the waves, and it also traps any sort of floating sediment, and as well as any other sort of pollutants, such as nitrogen and phosphorus, from entering our estuaries and polluting our waters and then harming those fish populations. Salt marshes and mangroves are also what we call carbon sinks, meaning that they store far more carbon than they actively release. And that's somewhere on the range of 10 times greater than a tropical rainforest and 3 to 5 times more per acre than a tropical rainforest. And then understanding how these environments, both salt marshes and mangroves, adapt and change to coastal development is incredibly important for their protection. We as geotechs can use our knowledge related to soil properties to enhance current design standards by understanding their shear strength, consolidation characteristics, and permeability, so that we can understand how they adapt to changes in loading, whether that be to us adding soil on top of it or changes in water levels over time. In addition, we also can help with a lot of the new movement that's happening towards things like beneficial use of dredged material by understanding what are the soils, are they appropriate to put on top of these marshes, or do that has a drastic impact. And finally, one thing that's also important to think about is we are actively involved with understanding, shoreline change and erosion, and how do we use these different types of plants to help stabilize those shorelines. The next infrastructure is going to be tidal flats, which are typically flat, fine-grained areas of estuaries found in front of salt marshes and mangrove forests that are covered with water and exposed to air twice per day. They're important habitats for a lot of organisms, ranging from algae, which are then foods for other organisms, and larger critters like crabs and worms, and also serve as a source of sediments for those salt marshes. Now, I'm going to be completely honest, nobody ever wants to build on a tidal flat. They're really soft, they're hard to get on, and they smell pretty bad. But we can use our knowledge as geotechs to be able to manage these habitats. So whether this be to contribute to oyster farming by understanding how and why different types of oysters live in certain environments but then fail in others, as well as understanding best management practices that can be used to help sustain those industries. The last two pieces of infrastructure I want to talk about are going to be oyster reefs and seagrass beds. So these two habitats are often submerged, with oyster reefs sometimes exposed at higher or lower tides, whereas seagrass meadows or seagrass beds are often always covered in water. Seagrass meadows are very important sources of food and shelter for many different aquatic species. Like their counterparts of salt marshes and mangrove forests, seagrass meadows provide storm and erosion mitigation as their roots stabilize the soil, their fronds slow down water waves and trap sediment particles, as well as filter out a number of pollutions from our water column. Information on their soil properties may be important for understanding how we restore them, as well as determining the best place to restore these meadows. Additionally, one thing we need to consider is when we're actively designing the new infrastructure, we need to make sure we're not doing anything to damage these important natural infrastructure. Oyster reefs, on the other hand, are underwater structures that are composed of both living and dead oysters. In addition to oysters, these reefs are habitats for a number of other aquatic species like mussels, crabs, and fish. Like other habitats there, they filter out pollutants from the water, help mitigate erosion, and attenuate wave energy. Sometimes, however, one of the things that we have to do is restore these, and we'll put new artificial reefs down, whether it be just rubble mounds, or I've even seen them do school buses, which is kind of cool. And we can use our information as geotechs related to consolidation characteristics, as well as bearing capacities, to understand, is this a safe place for us to put these oyster reefs, or is it just going to sink in and not actually do the purpose that we need? So today, I hope I was able to give you a lot of information related to what I think is a very important piece of infrastructure in our world. And in case you ever want to learn more, I have shown here on a slide some of the local estuaries in the United States. While this only shows 30 of them, there are many more available to you. These 30 are managed between coastal states and NOAA, or the National Oceanographic and Atmospheric Administration, to be able to connect people with their estuaries, as well as preserve them and keep them safe. So if you do live near one of these, I do encourage you to check them out, because they do a lot of really cool work in their communities. So thank you so much for your time today, and I hope that you got to learn a little bit more about a cool piece of infrastructure.